In this lecture, we are going to talk about secondary ion mass spectroscopy, in short, SIMS. We have previously discussed about X-ray photon electron spectroscopy, which the mechanism is like this. X-ray shining on the atom, electron will be ejected from the atom, and we can detect the signal from the ejected electron. For secondary ion mass spectroscopy, the process is sort of similar, but the mechanism is different. Instead of X-ray, primary ion particles was incident on the material surface, and the secondary ion particles will be ejected from the material surface and be detected by some detector. In detail, there are three modes to generate secondary ions. The first is direct collision. The first is direct collision scattering, where the primary ion interact with the surface atoms directly and eject ions from the material surface. This process is rather fast. The second mode is that the primary ion beam has no chance to interact or has no chance to collide with the surface atom, but instead the material will transfer the impact energy to the surface atom. The third mode is thermal sputtering. The secondary ion will be generated by the thermal effect generated by the primary ion beam. There are two different methods to do a SIMS measurement. One is static SIMS, the other is dynamic SIMS. Now we'll introduce a little bit about the SIMS instrument. In SIMS instrument, there are several components. The first one is primary ion system to generate primary ion beam. The second is a Wien filter to filter away unexpected primary ions. The third is XY deflector. And also there is an ion extractor or filter, and a mass analyzer, and at last a detector. We can draw a diagram of how the machine or how the instrument is working. Here is primary ion system, or we can say an ion source, which is to generate primary ion beam. And then this beam passes through a Wien filter and the XY deflector reach the sample. The secondary ion will be released from the sample surface and collected by an ion extractor, and then pass through a mass analyzer and reach the detector. After that, you can get a spectrum of the secondary ion mass spectroscopy. The ion source has different types. The first one is electron bombardment source. The second is plasma ion source. The third is liquid metal ion source. And the fourth is surface ionization sources. The Wien filter in the SIMS instrument is to select primary ions with certain mass. The ions that generate from the ion source have different mass, so the time passed through the system to the sample is different. So we need to remove the heavy ions and light ions so that we get more precise signal. By put a Wien filter, the expected ion will pass through, but the others will be blocked. We mentioned that there are two modes for SIMS test. One is static mode. This static mode is used to do some element analysis. The dynamic mode is used for depth profiling, which can generate 3D signal. We mentioned that the process of SIMS and XPS is similar, but why we use SIMS? There are several reasons. First, SIMS can do all element determination that exist in the period table. But for XPS, it couldn't do element like hydrogen. The second advantage of SIMS is the request of low concentration of materials or element, while for XPS, the concentration is rather high, which means the sensitivity of SIMS is better than XPS. The third advantage of SIMS is it can distinguish isotopes of elements, which couldn't be done by XPS. The fourth is SIMS can do depth profiling, while XPS just can detect the surface